Hello everyone, I am Purnima Subramanian. I am studying in Sri Venkateswara College of Engineering in the third sem Data Science. Today's my course is Operating Systems. In that my topic is deadlock. The subject code is BCS 303. My USA number is 1E23CD037. We will move on to the next slide, that is a deadlock. In that the introduction to deadlock is a situation in computing where two or more the processes are unable to proceed because they are each waiting for the others to release the resources. It's a critical problem in the concurrent programming that can lead to system resource wastage. Understanding the deadlock is essential for developing the effective resource management strategies in the operating systems. In this picture, we can see that how the processes are waiting for the resources assigning. And then we will move on to the next slide, that is the conditions for the deadlock. There are the four necessary conditions for the deadlock to occur, that are mutual exclusion, no preemption, hold and wait, and the circular wait. Mutual exclusion ensures that only one process can use a resource at a time. Circular wait implies a closed loop of the processes, each waiting for a resource held by the next process in the cycle. In this picture, we can see that four necessary conditions for the deadlock, that are here only we are already seen that mutual exclusion, hold and wait, no preemption, and the circular wait. For that the explanation is mutual exclusion. Process claim the exclusive control of the resources they require. Wait for the processes hold the resource already allocated to them while waiting for the additional resources. No preemption means resources cannot be removed from the processes holding them until the resources are used to completion. And then the circular wait means a circular chain of the processes exist in which each process holds one or more the resources that are required by the next process in the chain. We will move on to the next slide, that is mutual exclusion. What is a mutual exclusion? Mutual exclusion is a condition where the resources cannot be shared between the processes. If one process is using the resource, others must wait until it is released. This condition is crucial for the resources such as printers, disks, and also the memories. And then in this picture we can see that the mutual exclusion means access to share the resources by the several uncoordinated user requests must be serialized. Actions performed on the shared resources on the user behalf must be atomic. For example, directory management. We will move on to the next slide, that is a hold and wait condition. Hold and wait occurs when a process is holding at least one resource to wait to acquire the additional resources. This condition can lead to a scenario where the processes are indefinitely delayed while holding on to the resources. Preventing the hold and wait can be achieved through the resource allocation policies that acquire the processes to request all the needed resources at once. In this picture, we can see that how the hold and wait condition work in the three processes, that are P1, P2, and the R1, R2. And then we will move on to the next slide, that is the no preemption condition. No preemption is the condition where resources cannot be forcibly taken from the process holding it. If a process requests resources that is held by the another processes, it must wait until that resource is released voluntarily. This principle complicates the resource allocation and can contribute to the deadlock situations. And then in this picture we can see that the no preemption, no resource can be forcibly removed from a process holding it. Once a process or the thread gets a resource, it can be taken away from that. And then we will move on to the next slide, that is a circular wait. Circular wait is characterized by the set of the processes each waiting for a resource held by the next process in the set. This condition creates a cycle where the no processes can proceed, leading to a deadlock state. Detecting and breaking the circular wait conditions is crucial for the deadlock prevention. In this picture we can see the how the circular wait process will be held. It only happens when there is a process which are waiting for the other resources to finish. R1 is the held by and it waiting for the R1. R2 is the held by it waiting for the R2. R1 is the resource 1 and R2 is the resource 2, and P1 is the process 1 and P2 is the process 2. And then we will move on to the next slide, that is the deadlock prevention strategies. What are the strategies we can use for prevention of the deadlock? Various strategies can be implemented to prevent the deadlock, including the resource allocation policies and the system design changes. Once a common method is to enforce a strict ordering of the resource request to avoid the circular wait conditions. Another strategy involves the requiring processes to request the resource upfront, thus the eliminating hold and the wait condition. Deadlock preventions restrain the ways request can be made. Mutual exclusion not required for the shareable resources must hold for the non-shareable resources. Hold and wait must generate that whenever a process requests a resources, it does not hold any other resources. Require the process to request and be allocated all its resources before it begins the execution, or allow the processes to request resources only when the processes has none. Low resource utilization, starvation possible. And then we will move on to the next slide, that is the deadlock detection and the recovery. How to recovery from the deadlock and how to detect the deadlock. In this slide we can see that conditions. Deadlock detection involves the algorithms that monitor the system for the deadlock conditions and identify the processes involved in it. Once the detected, recovery strategies can include the terminating processes or forcibly preempting the resources. Recovery must be handled carefully to avoid the data loss and the ensure the system stability. In this diagram we can see that the deadlock detection, there are the two ways, that are the single instance and the multi instance. In that, wait for the graph or the safely algorithms. And then we will move on to the next slide, that is the example for the deadlock. Real world examples of the deadlock include the printer sharing in an office environment and the database transactions in a multi-user system. In a printer sharing the scenario, one user may hold the printer while waiting for a paper tray, while another user holds the paper tray. These situations illustrate how easily deadlock can occur every day computing the task. Here, deadlock is a situation where a set of the processes are blocked because each process is holding the resources and waiting for the another resources holding by the some other processes. Finally, the conclusion for this deadlock concept is deadlock is a significant challenge in the design of the operating systems and resource management. Understanding the conditions and the strategies for the handling deadlock is vital for the developers and the system administrators also. By implementing the effective prevention, detection and recovery methods, the risks associated with the deadlock can be minimized. Four conditions for the deadlocks are already seen, that are the mutual exclusion conditions. Each resource is assigned to one process or is available. Hold and the wait condition. Process holding the resources can request the additional conditions. No preemption condition. Previously granted the resources cannot forcibly taken away. And then the circular wait condition, that is must be a circular chain of the two or more processes. Each is waiting for the resources held by the next member of the chain. Thank you all. Please do like and share my video guys. Thank you.